When people talk about AI and computer vision, sometimes they compare it to a mirror. A common misconception is that because computer vision is rooted in data and algorithms, that it's a completely objective reflection of people. But that's not the case. Computer vision can warp things, depending on the biases reflected in its training data. This is an extremely challenging issue that the AI industry must address. Personally, as someone who grew up as a small minority in a predominantly white Appalachian city and later on spent most of my career in heavily male-dominated fields, I always felt the challenges of being someone who's different. I wanted to ensure the technologies we're creating are counteracting that instead of further putting people in these narrow boxes.
Sony has a lot of computer vision application across the board, from entertainment application to the sensors that we're building. When we talk about fairness in AI systems, we want to strive for AI systems to be working for everybody.
So the core mission for our AI ethics research team is to tackle fundamental unsolved problems around AI ethics. We've learned that a lot of ethical issues with AI technologies start at the data layer.
When we say bias, we mean that some systems may only work on very dominant demographics, people of a specific background, white, male, Caucasian.
We want to fix that. We need to have a technology that is fair to everyone and transparent on how we train the system.
What is it that we can do here in the space of AI ethics that has a really big impact? And we finally came up with this idea that actually there's this huge hole in computer vision in terms of the ethical principles around dataset collection.
The name of the project is FHIBE, which stands for Fair Human-Centric Image Benchmark. It's so important that computer vision models are checked for bias before they're released. But there wasn't any good ethical fairness benchmark that folks could use. And so we realized we had to create one ourselves. Computer vision is a subfield of AI that focuses on how AI sees the world. It shows up in everyday life. For example, if we have a phone that has face verification to unlock it or to do payments, there's some cases in China that raised a lot of questions in terms of whether the model was biased, where folks found their family members were able to unlock their phone and make payments. Maybe there weren't enough images of Asian people in the training data set, or maybe the model was not checked for bias before it was released. It can be both a huge inconvenience and also potentially an information security problem. That's why it's important to train and evaluate computer vision models on a large, diverse data set.
Let's say that we want to have a computer vision model that can recognize trees. So one way to do it is tell the computer vision model that this is a tree and this is not a tree. We need to collect lots and lots of images that will depict trees in different situations. When we're doing computer vision, sometimes we have the tendency of representing a narrow view of the world. If we only show images of trees with green leaves, it might not work if we haven't seen any image with orange or red leaves. So this becomes a humongous task. We need to collect lots of images, lots of data. This is why this is so important with the project that we're doing here. We try to cover all possible variations that can exist when capturing humans in images.
The big problem today in building AI systems is that they need a lot of data. And that data is not collected in an ethical and responsible way.
For example, web scraping is a very common method that has been used to accumulate very large data sets.
The internet is already skewed towards certain demographics, like Western people.
Web scraping has the advantages of being extremely inexpensive and very scalable.
People are uploading their images all the time to all sorts of different social media and other platforms. The issue comes when people then are taking those images and using them to train a computer vision model. That person probably doesn't even know that their images are being used in that way. It's obviously violating a lot of their rights.
FHIBE is an important landmark in AI data collection.
We built a diverse set of images and annotations of people to an extent and a rigor that has never been done before. And anyone can use this data set to test for fairness in their own AI models.
Our goal was to do the thing that people have been talking about doing for so long, how to actually curate data sets properly, be it in terms of representation, in terms of IP.
Overall, the project ended up being a multi-year project with many researchers involved because ethical data collection turns out to be an extremely challenging issue.
The trickiest part is collecting data through third parties or data vendors.
It's one of those things that when you see it on paper, you think this shouldn't be that difficult.
Data vendors are usually given a set of requirements, and these requirements are often things like age or skin tone or gender. It's usually quite basic.
The requirements document we gave to our vendors was somewhere between 30 to 50 pages.
I think their reaction was, nobody had ever asked for something this complicated before.
It's very common practice in the industry for one person to submit the photo and then another person annotates it. So you're just making guesses about the person in the photo. So it was really important for us to get the information about the person straight from the person themselves.
There are existing data sets out there that can be used for fairness evaluations, but by and large, they are built with scraped data. So that's one of the major differentiators for our data set. A very key component of this was ensuring that we had enough diversity of people in the images and also diversity in terms of the poses, lighting conditions, background conditions.
We have roughly 10,000 images in the data set. Those 10,000 images are from around 2,000 people.
We fairly compensated people in the process of collecting this data. We asked people for the consent. And moreover, we allow people to retract that consent, which is basically a human right.
FHIBE will be available on our public platform where researchers and developers are able to download the data set to test their models for bias in the human-centric computer vision space. We used FHIBE to test a wide variety of different computer vision models, including face verification, foundation models, and we found new biases that had not been documented before. We found that vision language models often reinforce gender stereotypes. For example, by associating long hair with she/her pronouns and short hair with he/him pronouns. Our initial results show just how important having an evaluation set like FHIBE is. It's so important that we have diversity, because if we're only testing our models on one type of person, it can have significant harms for everyone else.
It's very important for us that the whole community actually gets its act together and builds the technology on a foundation of ethical data.
Right now, it's very easy for folks to say that either they don't know whether their model is biased or they can't compare. With FHIBE, though, that is now possible, so there's no longer that excuse available.
We are a company for creators. We are creating the tools that benefit people and respect the rights of the individual, rights of the creators.
FHIBE is sort of a landmark, but it's not the end.
We are pushing forward the boundaries here. We are applying best practices. We've made that investment to create this for the community, but this is really just the starting point.